Good evening, everyone. Today we are going to look at trigonometry questions again. This is the third video on trigonometry, but today we are going to look at 2 marks and 3 marks questions that are few from the textbook and few of them are extra questions. Okay, so we'll have a glance at all the different varieties of questions that can be framed and solved. Okay, so looking at the first question, we have, if we read the first question, we have tan A, if tan A is 3 upon 4, we have to find the value of 1 upon sin A plus 1 upon cos A. We already know this type of questions. We've done this from the textbook. This is from the first exercise of trigonometry. When we wish to do such a question, the better option is that we select a triangle. We draw a triangle. Okay. And what kind of a triangle are we going to draw? We are going to draw a right angle triangle. Assume this to be a right angle triangle, children. A, we are talking about angle A. That means definitely the 90-degree angle is not A. So either you can choose this as angle A or this as angle A. Suppose I'm choosing this as angle A. Then this could be B and this could be C. The question gives us that tan A is 3 upon 4. Right? Now, if we look at the definition of tangent A, tangent of the angle A is here. It says tangent of any angle is its opposite side upon adjacent side. So we write here, this means nothing but opposite side of angle A upon the adjacent side of angle A. And that ratio is 3 upon 4. Can you quickly tell me which is the side opposite to angle A? The side opposite to angle A is the side in front of angle A. So that will be BC. And the adjacent side, definitely this is the hypotenuse, so cannot be the adjacent side. AC cannot be the adjacent side, that's your hypotenuse. BC is right in front of A, so that's the opposite side. So we know that AB is going to be our adjacent side. So we get AB is 3 upon 4. From here, we'll say let the common multiple be K or let the common factor be K. And hence we can say that BC is 3K and AB is 4K. Am I right? Am I understood, children? Now, the question part. What does the question ask? The question asks, second part of the question, we want to find the value of 1 upon sin A. Right? We need to find the second part of the question, which is, we need to find 1 upon sin A plus 1 upon cos A. So that means from the figure itself, what we had written, BC is 3K and AB is 4K. So using this information, can we find out the value of sine and cos? To find sine and cos, we will need the value of AC. And how are we going to find the value of AC? We are going to find the value of AC by Pythagoras theorem, right? So we'll do that part now. We'll say in triangle ABC, which is right angled at B this time. We've taken angle B as 90. By Pythagoras theorem, what are we going to get? We are going to get AC square is AB square plus BC square. Now AB is how much? 4K plus BC is 3K. And on simplification, we are going to get uh, this as 16K square, because 4 square is 16 and 3K square, which is 9K square, which is 25K square. So what did we get? We got AC square is 25K square, and therefore what is AC? Square root of 25, 5, and that of K square, K. Right? So we got this part where we wrote AC, we got AC as 5K. Now, we need the value of sin A. Next part, what is sin A? Sin A is opposite side of angle A upon the hypotenuse. Which is your hypotenuse? Which is the opposite side? Obviously, opposite side is BC and the adjacent side is AC. So this is going to give me what? BC is 3K, AC is 5K. So this ratio turns out to be 3 by 5. So we get here sine A is 3 by 5. Next in the question is cos A. Cos of any angle is what? Adjacent side of the angle. And here the angle is A. So adjacent side of angle A upon hypotenuse. Adjacent side of angle A, right? AB and hypotenuse is AC. What is AB? 4K, AC 5K, and hence we come to 4 by 5. So we get the value of cos also. Now what? What's next? We need to find the value of 1 upon sine. We need the value of 1 upon sine A plus 1 upon cos A. Right? Now we need to simplify this. So we know 1 upon, if sine is 3 upon 5, I repeat, if sine A is 3 upon 5, then 1 upon sine A will be the reciprocal of it, which will be 5 by 3. Similarly, if cos A is 4 by 5, 1 upon cos means reciprocal of it is going to be 5 by 4. And then it is just simplification. You take LCM, you're going to get LCM as 12, 3 4s are, and 4 5s are. So this is 20 plus 25, which is 45 by 2. And here is your answer. So we can say this is our answer. This is the value of 1 upon sine A plus 1 upon cos A. Very quickly, let's quickly look at it. What did we start with? Our first step was we started with the triangle, right? In the triangle, we marked angle A. Using tan A, we found BC and AC. We represented it in terms of K. Then using using AB and BC, we found AC by Pythagoras theorem. When we knew all the three sides, we found sine A and we found cos A. See, children, there are many different methods by which you can do it. You can use trigonometric identities to solve this, if you know the identities and if you remember them. If you use trigonometric identity for tan square, which is x square minus 1, then also you can find. Okay, by that method also you can find, or this is the basic definition method which we have used to find the value of 1 upon sine A plus 1 upon cos A. I hope you have understood this. Similar question. Look at the second question. It states that in triangle PQR, which is right angled at Q. So we have a right angled triangle PQR and it is right angled at Q. That means a right angled triangle is Q. At right angled at Q, we have P here, or you could place P over here, does not matter. And let me place R over. Further, what is given? PQ is 3 centimeters and PR is 6 centimeters. We need to determine angle QPR, this angle, and we need to determine angle PRQ, which is these two angles. Now, if I look at angle R, okay, we need to find the measure of angle R and we want to measure P. And when we look into the figure, we see that we know the opposite side of angle R. Which is the opposite side? PQ. We know the measure of PQ. We also know PR. What is PR? Hypotenuse. So you know opposite side and hypotenuse. And what do we know? We know the trigonometric table that we know for all the values. For all those who are new, let me just brief this quickly. How do we remember this easily? Entire trigonometry in this small table. I know it's a little cringe, but cringe things are remembered very quickly. So let's go with it. We remember this as old Ritik and his old Amisha. And the trigonometric ratios related to it are sine theta, cos theta, tan theta. So sine theta is opposite upon hypotenuse, cos is adjacent upon hypotenuse, tan is opposite upon adjacent. Hypotenuse upon opposite, when you go the other way around like this. So this is going to be your cosec theta. Hypotenuse upon adjacent is your sec theta, and adjacent upon opposite is your cot theta. Right? We know this table. We know the basic definitions of all the trigonometric ratios. So if I look at opposite sine and a hypotenuse, that means I need this trigonometric ratio, which is sine. But sine of which angle? R, because I know the opposite side of R and I know the hypotenuse. So we are going to start with the solution and we're going to say in triangle PQR, what is sine R? Sine R will be what? Opposite side of angle R upon hypotenuse. Am I right? Now, which is the opposite side of angle R? PQ. Which is the hypotenuse? PR. How much is PQ? Is the measurement given? Yes, it is 3 centimeters and PR is given as 6 centimeters. On simplification, we have 3 ones are, 3 twos are, that is 1 by 2. This is sine R, like yesterday, now, the previous questions. But sine of which angle is 1 by 2? Sine 30. So what do we get from here on comparing that angle R is 30 degrees. That means this angle turns out to be 30 degrees. Now to find P, what we are going to do? Next what we are going to do? We'll say in triangle PQR, angle P plus angle Q plus angle R is how much? 180. Why? Angle sum property of a triangle. P is unknown. Q is right angle, so 90. And angle R we just now found to be 30. So what do we get? Angle P plus 120 is 180. So angle P is 180 minus 120. Angle P is 60. So we found both the angles. What were you supposed to do in this question? What were we supposed to do in this question? Not just you. Using sides. We observed that we had two sides, opposite side and the hypotenuse of angle R. So using the trigonometric ratio sine, we were able to find the angle. Right? This is a little a different one. Can be asked as a 2-mark question or an MCQ. Okay, moving on to the next one. Now this is also an interesting one and an easy one. Now we are given that sine theta plus cos theta is root 3. And we have to prove that tan theta plus cot theta is 1. Right? The question is in the form of sine and cos and the answer is required in the form of tan and cot. So why not look at both and then decide what should be the next step for solution. LHS is already sine and cos. So let us understand what is the right hand side saying. So we'll say here consider RHS. Consider RHS. We are starting with the RHS to understand actually what is required. We are given tan theta plus cot theta. We need to prove that this is equal to 1. So if I try to change tan and cot in terms of sine and cos, we know tan theta is nothing but sine theta upon cos theta. Very good. And cot is cos theta upon sine theta. What is the LCM going to be? The LCM is going to be sine theta cos theta. So we have a sine square over here, a cos square over here, and in the denominator we already have sine theta cos theta. Right? What is sine square plus cos square? 1 upon sine theta into cos theta. Had it been sine plus cos, we could have replaced, but we have 1 upon sine theta cos theta. Right? So we know we need the value of this ratio. So then we come back over here to the RHS part. To the LHS. Okay. We'll look at the LHS and we'll try to simplify and bring it in this term. Okay. So we have over here sine theta plus cos theta is root 3. Now, do I need sine individual, cos individual? No, I need it as a product. So what I'm going to do is, we know that if a plus b is given to us and we need ab. So what do? We square both sides. So squaring both sides, what are we going to get? We are going to get sine theta plus cos theta is root 3 squaring both sides. So the best part is square and root gets cancelled, nullify each other. And so this becomes 3. And over here I have sine theta plus cos theta the whole square, which is of the form a plus b the whole square. Now what is a plus b the whole square? A square plus b square plus 2 sine theta or a b. 2 sine theta cos theta. So we got a plus b the whole square is a square plus b square plus 2ab is root 3 square, which is 3. Now, do we know what is the value of sine square plus cos square? We know it. It is 1. 1 plus 2 sine theta cos theta is 3. So, what is 2 sine theta cos theta? 3 minus 1, which is 2. And this multiplication will come down and become division. So, we get that sine theta into cos theta is nothing but 1. 2 upon 2, 1, which we replace over here. We are going to get 1 by 1, which is 1. So, I'm sorry. That is how we proved that tan theta plus cot theta is going to give us 1. If sin theta plus cos theta is root 3, we are going to get tan theta plus cot theta is 1. I hope you understood. Did you understand how to get the solution, how to think about it? Rather than directly deciding as to what is to be done, always start with looking at your LHS and RHS both and then decide what is to be done. Now, in this question, what we did, we first realized that the question is in the form of sine and cos, and the proof that is on the proof that part or the RHS part is on the of the form tan theta plus cot theta, right? So if I look at tan theta plus cot theta, we knew that we could simplify it in the form of sine and cos. So we just checked and we brought it to the simplest form, and then we decided how are we going to go about with the given part. I hope this is understood. Please, I repeat myself, please note down these questions. After watching the video, pause yourself and solve it immediately. Only then it makes sense of revision. By just watching mathematics, you're not going to understand or you're not going to be able to recollect questions. Okay, now moving ahead, we are given that we have triangle OPQ. We have triangle OPQ. Let's draw. Right angled at P. The right angle is at angle P. Vertex P over here. So Q and R, wherever you want, you can put. I'm putting Q over here and putting R over here. What else is given to us? We are given that, I'm sorry, I've marked wrong angles. It's O, not R. POQ. OP is given as 7 centimeters. And the difference of OQ and PQ is 1. What is given to us? OQ minus PQ is 1. So if I call PQ as X, unknown term, I'm going to get OQ minus X is 1, and therefore OQ is equals to 1 plus X, and therefore from here I get this as 1 plus X. Next, what you're going to do? What should be our plan of action to solve this further? It should be that we know all the three sides in terms of X, 1 plus X and 7. Let's simplify and find the value of X. To simplify and find the value of X, what are we going to do? We shall apply Pythagoras. So we'll write here next. In triangle OPQ, angle P is 90. Therefore, by Pythagoras theorem, what are we going to get? We shall get that OQ square is OP square plus PQ square. Hypotenuse square is side 1 square plus side 2 square. How much is OQ? OQ is 1 plus X. the whole square, OP is 7 square, and PQ is x square. Now A plus B the whole square again is going to give me 1 plus 2x plus x square is 49 plus x square. We can cancel out x square. We are left with 2x is 49 minus 1, which is 48 by 2 is x. Hence, x is 24. So, we found the sides. We'll write it therefore. PQ is 24 centimeters and OQ is 1 plus x, which is 1 plus 24, 25 centimeters. So, we got this as 25 centimeters and x as 24 centimeters. This is a textbook question, children. This is a solved example question, which is very important from the exam point of view. So hence I picked it up for the revision part. Now it's simple. We need the value of sine q. Obviously, what is the definition of sine? Opposite side of angle q upon the hypotenuse. Quickly tell me which is the opposite side of angle q. PO. And the hypotenuse? OQ. How much is PO? 7. OQ? 25. This is your answer. Sine q. Okay, हो गया? Right? Right. Textbook question, you can revise this anytime, and it is definitely very important from board exam point of view, be it a basic paper or a standard paper. It is an important 2-mark question. Fine. Moving on with the next question. Let's quickly move with the next question. Move to the next question, which is prove that. Now, this question of prove that using identities. Many children face problem with this question. So with this question, which is sine theta minus cos theta plus 1 upon sine theta plus cos theta minus 1 equals to, we need to prove this is equal to 1 upon sec theta minus tan theta. Now what are we going to do in this case? I'll teach you a very simple method. Follow that whenever you get this question. In 3 or 4 steps, you'll get your solution. You'll be able to prove the right hand side. Okay. So the first thing to understand is the question. That's what I'm going to write again. I'll say consider the RHS part because we are going to simplify RHS. I'm really sorry, not the RHS. We are going to simplify the LHS, left hand side. What is your left hand side? Sine theta minus cos theta plus 1 upon sine theta plus cos theta minus 1. Our LHS is in the form of sine and cos, and RHS is in the form of sec and tan. If you look at sec theta, if we look at sec theta, what is sec theta? Sec is nothing but 1 upon cos theta. And what is tan theta in terms of sine and cos? That is tan theta is sine theta upon cos theta. Means in sec and in tan, the denominator has cos. Does a question have cos in the denominator? Numerator has a denominator? No. So what is the first step going to be that I want you to remember is, first important step, dividing each term by cos theta. I hope you understood why we are dividing by cos theta. Had the question been 1 upon say cosec minus or plus cot. So in terms of cosec, we have 1 upon sine. In terms of cot, I will have cos upon sine. The denominator would have sine. Then we would have divided by sine theta. But here in this case, we need to prove it is equal to 1 upon sec theta minus tan theta. So 1 upon sec is 1 upon cos and tan is sine upon cos. So that is why we've chosen to divide by cos theta. Okay, moving ahead. If I divide each term with cos, we are going to get what? Sine theta upon cos theta minus cos theta upon cos theta plus 1 upon cos theta. Right? And we are going to divide it again by the denominator, each term by again cos theta. In the denominator, each term also we have to divide with cos theta. So we are going to get this as, what is sine upon cos? tan theta. Cos upon cos is 1 and 1 upon cos is sec theta. Here we are going to have again tan theta plus 1 minus sec theta, right? So our first step is over. For the second step, what are we going to do? I hope everyone has understood why we've divided by cos. Second step will be we bring two, we rearrange this and bring 1 as the last term. So we are going to get sec theta plus tan theta minus 1 upon, or rather we can follow the same order that is there. The only thing is, we just write it as tan theta plus sec theta minus 1 upon tan theta minus sec theta plus 1. So we understood the second step. I hope. Now in the third step, what we are going to do, I'll just put this arrow sign so that you understand that there is a step involved over here. Now in the next step, what we are going to do, we are going to put brackets only in the numerator. Or let me first tell you what to do next and then we'll come here. Next is whatever is your RHS, we'll multiply and divide by the same. We have tan theta plus sec theta minus 1 upon tan theta minus sec theta plus 1 into, we have sec theta minus tan theta, no? So we'll multiply and divide by the same, sec theta minus tan theta upon sec theta minus tan theta. We have not changed the question. We have just multiplied with whatever is your RHS. Multiplied and divided. So at any moment you cancel and we get back our original step. Now is an important step. What we are going to do? We want our answer in the denominator. So the denominator part we leave as it is. We are not going to do anything to it. We will leave it as it is in the denominator. No changes, no simplification, nothing. And we'll write here in the next one, tan theta plus sec theta in one bracket minus 1 into sec theta minus tan theta, which is the numerator part. I haven't solved it yet. Okay. I've just written it together. And in the denominator, we leave tan theta minus sec theta plus 1 as the first bracket, and second bracket is sec theta minus tan theta. As told, we are going to do nothing to our denominator. Nothing at all to the denominator. Okay. So we leave it as it is. Nothing to be done to this. Bring it down every time without any changes. So we are going to get what now? This is first term, second term multiplied by another term. So first with first and bracket with second. We are going to multiply that. And it's, if you see, we have sec plus tan, sec minus tan, sec theta plus tan theta into sec theta minus tan theta, and the minus 1 times sec theta minus tan theta. As told, nothing to do in the denominator. We'll just rewrite it as it is. We are going to get tan theta minus sec theta plus 1 into sec theta minus tan theta. Right? We've understood till here. So what is the next step then? What is a plus b into a minus b? A square sec square minus tan square. When I open the bracket multiplying with minus 1, we are going to get sec theta minus into minus plus tan theta. Denominator as it is again. Nothing to do in the denominator. We have tan theta minus sec theta plus 1 times sec theta minus tan theta. Now, by identity, we know that 1 plus tan square theta is sec square theta. So then what is sec square theta minus tan square theta? We transport tan square on the other side. So we are left with 1 over here. So we are going to get this is nothing but 1. This is 1 minus sec theta plus tan theta in the numerator. I hope we've understood how we are getting this. We got this from the identity. Correct? We told that this part sec square minus tan square. Sec square minus tan square is 1. And we have sec theta plus tan theta. In the denominator, we have tan theta minus sec theta plus 1 times sec theta minus tan theta. I'm sorry. Right? Now look at the numerator carefully. Tan theta minus sec plus 1 means these two brackets are identical. We can cancel them and we get 1 upon sec theta minus tan theta. Let's look at it again. Looking at our question, we decided that we are going to divide by cos. Then we brought 1 as the last term. In the next important step over here, in the next important step, what did we do? We multiplied and divided with whatever was the RHS. The RHS is sec theta minus tan theta. So we multiplied and divided by sec theta minus tan theta. Then we saw that sec theta minus tan theta in the RHS is in the numerator. Sorry, is in the denominator, not in the numerator. It's in the denominator. So we leave the denominator untouched. Nothing to be simplified in the denominator. We do the multiplication in the numerator. And on simplifying, I'm sorry, on simplifying, we got 1 upon sec theta minus tan theta. I hope I have understood. You have a similar question in the exercise. This again is one of the solved examples. If you follow these rules and if you simplify the question given in the exercise, I'm pretty sure you're going to be able to do this question. And this question again, children, is important. It can be asked as a 3-mark question or a 5-mark question depending upon the basic or the standard paper. Okay, now there's a bonus question, a very different question where we are looking at geometry. Okay, the geometrical meaning of trigonometry. I repeat, we are looking at the geometrical meaning of trigonometry. Little bear with me till I just adjust the question. Yeah. Okay. The question is little different. What does it say? It says, shown below is a semicircle. So we have a semicircle of radius 1 unit. 1 unit, that means, can I say that OB, OC and OA, all these three are 1 unit each. We are not saying 1 centimeter, we are saying 1 unit. It could be anything. Okay, it's 1 unit. So I'm just marking it for once. I'm not going to write everywhere. Make necessary constructions and show that sine of theta by 2. Now we are given only angle COD as theta, angle and CD is perpendicular to the diameter, and we want to prove that tan of theta by 2 is equal to sine theta upon 1 plus cos theta. Read this question again to yourself, student. This is little different, but not a difficult one. Okay, not a difficult one. So in this question, what we are going to do, we are going to make a construction. Let's see what construction will help us. Let's join O to C. We are joining O to C, is already been given, and that is 1 unit. We are joining B to C. Assume this to be a straight line, children. Let me try it once again. We are joining B to C. Better. Okay. Now, what do we know? We know that the arc AC is subtending this angle at the center. Which angle is this angle? Which angle is this? Quickly tell me. This is angle uh, COA, which is theta. The same arc, which is the same arc, the arc is AC, is subtending another angle. But where? At a point on the circle. So in 9th standard, we had learned a relation between them. That if this is theta, this is going to be what? Theta by 2. Am I right? Am I understood? So I hope you have understood why this is theta by 2. Right? I hope everyone has understood why we got this as theta by 2. Now, simple. This is theta by 2 and we want tan. We are going to look at which right angle triangle? Definitely we are going to look at this right angle triangle. This is the right angle triangle that we're going to look at for the values of tan. Right? I don't know whether this is visible to you. So let me redraw it. Okay, this is theta. This is C. This is D. We have an O over here and we have a B over here. This is theta by 2. And then OC is theta. Right? So if we want tan theta by 2, we are talking about this angle. For now, let me just get rid of the other part. This part. Okay. We have found this angle to be theta by 2. Now, tan of theta by 2 is what? Opposite side CD upon the adjacent side BD. This is tan theta by 2. We also need what? Sine of the angle. We need sine of the angle also. So we can write here sine theta. Where is theta? Theta is this. Which right angle triangle are we going to see? We are going to look at this right angle triangle now. What is sine? Opposite side CD upon the hypotenuse. In this triangle, which is the hypotenuse? OC. How much is OC? OC is also the radius. So can I say sine theta is CD upon 1? So I say that sine theta is CD. Right? Likewise, we say cos theta. Because my question is sine and cos both, no? So what is cos theta? Adjacent side DO upon the hypotenuse OC. And we know OC is 1. So we get what? We get cos theta is DO. Let's look at the question again. What is tan theta by 2? We wrote tan theta by 2 is CD upon BD. What is CD? From your CD is sin theta. What is BD? BD is this part. DO plus BO. BO plus DO. What is BO? BO is the radius, so that's going to be 1. What is DO? DO is cos. Hence proved. It's very simple. Things which look complicated, no, they are usually very simple. You just have to understand this. And the reason to take up this question is you understand that what construction can be made. If we are given an angle, how to find out the half of the angle. And what is the reason? The reason that we used is angle subtended by an arc at the center is twice the angle subtended by the same arc at any point on the circle. We have done this property in 9th standard, which we have applied over here. I hope whatever we have done today, children, I really hope that you will benefit out of it. You are going to do your revision. You're going to do the extra questions and make a note of all these questions and simplify them. Solve them in your books. Then it makes sense, right? Okay, chalo then. With this, I say bye bye and happy practice.